Hello, in this tutorial I'd like to talk about ventilation in BE15. And as you can see, there is a lot of headlines here that we need to talk about. I'll first go to the guideline where you can see a schedule showing all the headlines that we have in the ventilation. And as you can see, we have other buildings down here, and then we have balanced mechanical ventilation, and as you can see, we have a lot about the ventilation system that we have to take care of. So this is the all. If we go to the program, then we have here ventilation, and these are the zones that we have. And if you think about the lesson we had about ventilation, where we divided the building into different zones, where we had the airflow in these zones, and we find it. So if you have rooms where you have the same airflow, you can actually add them together in these zones here. And then you find the areas for these zones. Then you have here, if you have the FO is how much you use the ventilation, and if you use the ventilation in the whole day of when the building is open, then it's 1. If you only use it a part of the time, then you can put it in percentage there. Then we have the mechanical ventilation, and the mechanical ventilation is the airflow that we found in the lesson about ventilation, where you have the airflow for that zone. And you have to remember that this one has to be in liter per second per square meter. And if you remember back on the lesson we made a column for the different rooms where we did write energy frame, and that's the column that you use and put in here. Then we have the temperature efficiency here, and the temperature efficiency is for the unit, and that's how good the unit is to use the heat from the outgoing air to heat up the air coming in to the room. And that we need to look up when we decide what kind of unit we're using. If we go to the example here, where we have to first find out how much air do we need for the whole building, and add that together. And for example, in this this example here, I have 2,160 cubic meter per hour. So I have to find a unit that can produce that big an airflow. So if I go to the home page, South, to where I can find different units, then here, and then I go to products, and I decide I want a counter flow unit. You might have done this already, I'm just repeating. Then I click here down on this one here, and here you can see I have different units here, and this one here goes from 780 to 3,920 cubic meter per hour. So I'll go into this unit, and then the temperature efficiency here, and then I have the airflow down here, and I have 2,100, and I go up here and can see that the temperature efficiency is 81. So that means that in the energy frame I write 0.81 here. In the temperature for the incoming air is always 18, so you put 18 here. This column here is if you have an electrical heater on the unit, then you put 1. If you don't have an electrical heater, then you put 0. And as we have district heating, if we have a radiator on the in-blowing air, then it will be from the district heating, so we never have an electrical heater here, so it will always be 0. Then we have the natural ventilation here. And the natural ventilation is the infiltration, so that's all the small gaps that we have in the building. And in the daytime, it's 0.13 because we open up windows and doors. And therefore, we have here the QIN, and that's infiltration in nighttime. And that's smaller than in daytime because we do not open up windows and doors in the night. So therefore, it's 0.08. Then we have the cell value, and the cell value is the value for how much energy we allow to use to move the air around in the system. And there is a demand for that in the building regulation, and I have written it in the guideline. If I just go to the guideline here and go down, then you can see down here that in chapter 839 you can see that the limit is 1800 joule per cubic meter. Then we have the next, and that's mechanical ventilation in summer, and that's the same as we have in winter. Then we have the natural ventilation in summer, in daytime, and that's also 0.13. Then we have mechanical ventilation in the night, and that's 0 because we turn it up. The building is closed in night, so therefore it's 0. And then we have the natural ventilation in the nighttime, and the same as in the winter, it is 0.09. So that's what we have. Then you might have some areas where you have natural ventilation, and these areas you also put in here. And then it's only the one about natural ventilation where you have QN you need to put in, and that in natural ventilation will be 0.3. That's also the demand from the building regulation, that's the air change that we need to have. So 0.3 in natural ventilation in day and night in winter, and day and night in summer. So that's what you need to fill out. Now I'd like you to go to the assignment that you have. The assignment, and the assignment here you can see you have the ventilation and the ventilation for the building, and that you need to fill out. Thank you so much and see you soon.